Thermodynamics is a branch of science which deals with heat and work. For example, if you are subjecting some work to a body, and this body will be completely converts this work into heat. That is the reason why work is a high grade energy. So the work will be directly converted into heat. But if some heat is subjected to a body, we are supplying some heat to a body. We don't know what this body is. That means, irrespective of what this body is, the work is completely converted into heat. But in case of heat, when subjecting the body, it is not a guarantee that this body is producing some work. So, for example, if you are heating a metal, now the heat will be converted into expansion of material, and some heat will be escaped. So, or some the body may convert into heat, convert into work, or may not convert into work. So that is the case. So what's happened? That's the reason why heat is not guaranteeing that heat will be completely converted into work, because we are not sure of the process. The process is trying to deliver some heat or not. So that is the reason why the Kelvin's Planck has stated that whenever we are supplying some heat to a heat engine, Q1 amount of heat is supplied to the heat engine, this heat engine will take some amount of work, only some amount of work to convert into heat, to convert into work, and some heat will be rejected to the atmosphere. That is sink. This is source reservoir, and this is heat engine. It is a cyclic heat engine. So this is Q2 amount of it. This is what's called second law of thermodynamics. That means whenever you are heating this metal, the metal is expanding by itself, thereby doing some work of expansion, and the work required to expand is somewhat limited, and the remaining work will be rejected to the surroundings. So if Q amount of heat is being Q1 amount of heat is being given to this metal, the work W is carrying out because of the expansion, and some heat Q2 will be rejected to the system. So that is the reason why this work is equal to Q1 minus Q2. That means you're saying heat is greater than work. That means Q1 is the heat. This Q1 is greater than or transferring into work. So by what amount? So Q1 is equal to work plus Q2. So Q2 amount of work, it is by default it is rejected into the atmosphere. So this is the second law of thermodynamics. So second law of thermodynamics is that the heat engine will absorb Q1 amount of heat, and this Q1 amount of heat, part of the Q1 will be used to deliver work, and some remaining part will be ejected to the atmosphere. So in the same case, and this is a reservoir. This is a reservoir, and the reservoir you are supplying some work to it. You are supplying some work to the reservoir. Now this work will take heat from the sink or refrigerate sink. Q2 amount of heat will be taken from the sink, and this both will supply heat to the reservoir R. So Q1. So here W plus Q2, these are the two inputs to the reservoir, the refrigerator, and these two will be rejected to the reservoir Q by amount of Q1. So this is the Clausius statement. So the work is completely converted into heat, and also part of heat will be taken from the sink and it will be subjected to the reservoir. So this is a Clausius and Kelvin Planks statements, which is saying that heat is a lower grade energy and work is a higher grade energy. Work will be completely converted into heat, but the complete heat is subjected to the system, only part of which will be used to deliver the work, and the remaining part will be subjected separate to the atmosphere. So this is, for example, 1, 2, 3, 1. This is a cycle. In process 1 to Q1 amount of heat will be supplied. In process 2, 3, W amount of work will be delivered to the system. And in process 3, 1, Q2 amount of heat will be subjected to the atmosphere. So that is what I would like to discuss in this small video session about the heat and work. And it is the second law of thermodynamics. Thank you for watching the video.